Hello, my name is Deidrielle Bailey, and today we will be discussing the disease poliomyelitis or polio. Let's begin this discussion by answering the question, what is polio? Poliomyelitis or polio is a highly contagious disease of the nervous system, which is known for its ability to cause paralysis. Polio also has the ability to cause other illnesses, such as mild cases of respiratory illnesses, gastroenteritis, and malaise. Of those diagnosed with polio, fewer than 1% are affected with the paralytic form. In most cases, individuals are asymptomatic, and others may exhibit milder symptoms such as headache or fever. Let us now continue by discussing the background of this disease. The name poliomyelitis originates from the Greek word polio, meaning gray, and myelin, which means marrow. Poliomyelitis is a member of the genus Enterovirus and belongs to the Picornaviridae family. Viruses within the Picornaviridae family are small enveloped viruses which contain an RNA genome. The poliovirus has single-stranded positive sense RNA genome that is approximately 7,500 nucleotides long. The poliovirus is known as the most significant, simplest virus due to its short genome and simple composition. It is believed that polio existed in ancient times due to the ancient Egyptian pictures that existed from 1403 to 1365 BC. The individuals within these pictures appeared to be walking with sticks and had deformed legs. English physician Michael Underwood gave the first clinical description of polio in 1789. He described the disease as a debility of the lower extremities. Polio was once known as Hindman disease because of the contributions made by the physicians Jacob Hind and Carl Oscar Medin in 1840. Polio first entered the United States in the summer of 1894. This outbreak terrified the country. Each year, more adolescents and young adults were affected by this disease, with an increase of paralytic cases. More than 27,000 patients were reported, and more than 6,000 died. In New York City alone, there was a reported 2,000 deaths. In 1950, a breakthrough came when polio vaccines were introduced by Salk and Sabin. There was a tremendous decrease in the number of cases. Within a year's time, the cases dropped from 58,000 to 5,600. A second wave of immunizations caused another decline in cases, and in 1961, only 161 cases were reported. Now that we know the background of this disease, let us now discuss the pathogenesis of polio. The poliovirus begins by entering the oropharynx. The virus then multiplies in the tonsils, lymph nodes of the neck, and the small intestine. Because the throat and small intestine are the primary areas of multiplication, initial symptoms are sore throat and nausea. There is a 2 to 35 day incubation period. The virus enters the tonsils and lymph nodes before entering the blood. If the virus enters the bloodstream, this leads to a condition known as viremia. Viremia causes the virus to penetrate the capillary walls and the central nervous system. When this occurs, it can lead to cell death and paralysis. After 3 to 5 days of exposure, the virus is shed in stool or recovered from throat swabs. During this time, individuals infected by the disease may show little to no symptoms. Let's now discuss the epidemiology of polio. The disease poliomyelitis has appeared in epidemic form. It became endemic and then reduced to near elimination. In many European countries and North America, the polio epidemic began in the late 19th century. Polio then became a global disease which appeared annually. The creation of the poliovirus vaccine in 1955 led to a reduction in cases. Wild polioviruses were eliminated from the United States by 1972. As immunizations became available worldwide, the number of paralytic cases also drastically reduced. Although wild-type 2 poliovirus was eliminated in 1999, types 1 and 3 continue in areas of Asia and Africa. There are many challenges faced in the final eradication of the polioviruses. These challenges include continued transmission in wild reservoirs, reinfection of polio-free areas, outbreaks which are caused by circulating vaccine-derived polioviruses, and continued excretion of vaccine-derived polioviruses by a few vaccinees with B-cell immunodeficiencies. There was a study conducted in order to determine whether or not the inactivated poliovirus vaccine should begin at 14 weeks or older. The research was conducted due to the cessation of global oral poliovirus vaccine OPV. The study focused on 3 different 2-dose IPV schedules which begin before or at 14 weeks of age. In order to conduct this study, randomized trials were conducted at two separate sites. 987 healthy infants ages 6 weeks of age were given vaccinations at random. The infants were randomized in the categories of 5 arms. The infants received 2 doses of the vaccination at different ages with and without oral poliovirus vaccine. The study presented the data for the 3 inactivated poliovirus arms. Arm C received inactivated poliovirus at 14 weeks and 9 months. Arm D received inactivated poliovirus at 6 weeks and 9 months. And Arm E received inactivated poliovirus at 6 and 14 weeks. Of the 987 children, 936 received vaccinations with the intention to treat. The data concluded that there was a greater than 99% response to all 3 polioviruses in those categorized as Arm C. There was a 77 to 81% response in Arm E, which was less than Arm C. There was a 98 to 99 immune response in Arm D, which was greater than arm E but less than arm C. Based on this research and the evidence provided, 2 full inactivated poliovirus doses can be administered beginning as early as 6 weeks of age. Let's now discuss the transmission of the disease poliomyelitis. Poliomyelitis is transmitted through the fecal-oral route. The virus is able to spread rapidly in areas of poor sanitation. It usually appears during the summer months in temperate regions. Polio is primarily transmitted in ingested water that is contaminated with feces which contain the virus. Infants that were exposed to the virus are usually protected through the antibodies of the mother. In this case, infants were usually asymptomatic and were provided with lifelong immunity. Now that we have discussed how this disease is transmitted, let's move on further and discuss how the disease is diagnosed. In order to diagnose this disease, polymerase chain reaction is used for detection. This can be done through isolation from samples of blood, throat swabs, stool, or cerebrospinal fluid. Stool samples are the primary source used for detection. 2 samples of stools must be collected within 24 hours within 2 weeks for ideal isolation. The virus can be isolated from the blood, but is not of diagnostic importance. Once the cell cultures are inoculated, cytopathic effects on the cells can be observed. Because the eradication of polio is coming to a close, it is imperative that detection and diagnosis are done promptly for new outbreaks in order to enable an effective response to such outbreak. Now that we have discussed the diagnosis of this disease, let's move on and discuss treatment and prevention of poliomyelitis. There are 2 types of vaccines available to provide immunity for polioviruses type 1, 2, and 3. The Salk vaccine developed by Jonas Salk consists of viruses for all 3 types which have been inactivated by treatment with formalin. This vaccine requires a series of injections. This vaccine serves to reduce the risk of vaccine-associated paralytic polio. The Sabin vaccine, developed by Albert Sabin, contains living attenuated strands of the virus in a suspension. This vaccine is ingested. The Sabin vaccine is cheaper to manufacture and simpler to administer. Salk and Sabin conducted several trials on their relatives, pets, and school children in order to successfully develop a vaccine. These vaccines have played a tremendous role in the journey towards polio eradication. Vaccinations are considered to be effective methods of intervention in order to control vaccine-preventable diseases such as polio. In this presentation, we discussed the disease poliomyelitis or polio. We begin the discussion by defining what polio is. We define polio as a highly contagious disease of the nervous system that is known to cause paralysis. After defining the disease, we then examine the disease's background information. We went on to discuss the pathogenesis and epidemiology of this disease, and then discuss research that was conducted based on poliomyelitis. We continued by discussing the transmission of the disease and ways in which the disease is diagnosed. To conclude this presentation, we discussed the ways in which poliomyelitis can be treated and prevented. Thank you.